So let's work on the Lewis structure for Cl2O. A lot of times for simple molecules, the first element will be the central atom. But when you have two elements that are first, like see this, you have two chlorines, then that indicates to me that the oxygen is in the middle. So I would have oxygen in the middle and two chlorines on the outside. Now you don't have to draw it symmetrical in 180 degrees like I have it here, but it's just how my mind likes to see it. So first we draw this arrangement, this skeletal arrangement, and then we need to make sure we know how many valence electrons. So chlorine is in group 7A on the periodic table, and for the main group elements, the group number in front of the A tells us the valence electrons. So chlorine has 7. We have 2 chlorines in this formula, so chlorine would bring 14 electrons. Then we have oxygen, which is in group 6A, so it has 6 electrons. There's only one oxygen in the formula, so that would bring 6. So we have a total of 20 electrons that we need to use. Now that number is super important because we have to be able to use those 6 valence electrons. So now we need to work on the Lewis structure. So the first thing we would do is draw single bonds between the elements. So if I drew a single bond here and a single bond here. Now that uses 4 electrons, so if I'm just thinking about it, I still have 16 electrons that I need to use to complete my structure. So the way you apply these 16 electrons is first go to the periphery, which means the outside or on the edge, the atoms on the outside. We're going to add lone pairs to give each one of them 8. So if you have a single bond, then it will take 3 lone pairs. So on that chlorine, and on this chlorine. So now if I count my total electrons, I have 2, 4, 6, 8, 10, 12, 14, 16. So 2, 4, 6, 8, 10, 12, 14, 16 electrons. So I have used the total of 16 electrons. So now, in order to complete this, I've used only 16 electrons. I've placed 12 more, so I placed 12, so I have 4 electrons left over. Now, any electrons that would be remaining would go on the central atom, and so I put these 4 electrons as represented by 2 lone pairs on the central atom. Now, this let me step back. Before I go any further with this, I always check 2 things. I make sure that my elements each have 8. So I see this has 2, 4, 6, 8. Then oxygen 2, 4, 6, 8. And this chlorine 2, 4, 6, 8. So they all have 8 valence electrons represented. And then I also make sure I only used the 20 electrons that I started with. So 2, 4, 6, 8, 10, 12, 14, 16, 18. What am I doing? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I was counting each electron as 2. Well, that gets you figure out pretty quick you're doing that wrong. So this would be the Lewis structure that I would expect for Cl2O. Now to figure out the shape, you'd be looking at your central atom, which is oxygen. And if I look at oxygen, it has 2 atoms that surround it because it has a chlorine on each side. And it has 2 lone pairs. So using the table about of shapes in your textbook or that was handed out in class, something that has 2 atoms and 2 lone pairs is the shape bent. Sometimes this could be called tetrahedral bent as well, because there's actually 2 bent structures. Now, to decide if the molecule is polar or not, there's a couple questions that we ask. The first question I always ask myself, looking at the central atom, the first question is I say, are there lone pairs? And lone pairs on a central atom make that molecule polar. And so I don't ask the other questions, have to do with the surrounding atoms, and it's discussed in the polarity video, but I can just stop here. Lone pairs on the central atom make a polar molecule. If there are no lone pairs on the central atom, then you have to look at the elements that are attached to that atom. And again, that's discussed in the video on polar molecules. So I hope this helps you.